We will continue looking at linear systems. However, we will use a different way of solving them called substitution. Below are the steps that we will be following. You can pause now or you can continue and see them in action. The substitution method, the first way we're going to do it is we are given two equations like we were before, and this time we're going to start by solving for y in equation 1. So what I need to do is isolate y in equation 1, and so I will go ahead, I think I might have said 2 before. So let's go ahead and to do that, starting out with that equation, getting it a little closer to where we're working here. And to substitute y, I'm going to do the shortcut here, and I need to add x to both sides. It eliminates x on this side, leaving y only. And then by adding x on this side, or crossing the river, we're going to change its close or its sign as we've been using, and we still have a positive 1. Again, I put the x first to look like our favorite slope-intercept. All right, the next step that we want to do is going to be that we will substitute our solution here for y, x plus 1, into the second equation. So what that means is I'm going to have 2x plus, and here is where I'm going to substitute. This is a plus y, so I'm going to go ahead and substitute in what I just solved for y. I put it in parentheses just to really overemphasize that it's the same quantity, I guess you could say, as I had here, or the same solution. And now I can go ahead and solve this time for x. First thing I need to do is put my like terms together. I now have 3 x's, the 2x plus this other positive x, and I have my 1. This is going to equal negative 2. Now I'm going to subtract 1 from both sides, leaving me with 3x equals, and if it was subtracting 1 here, or combining a negative 1, gives me a negative 3. If you don't feel comfortable taking these shortcuts, that's fine. I'm doing it mostly because I'm writing with my finger, and we keep repeating this, and I'm also being careful of the time we have on the recording. So I have now solved for x. I have x, and negative 3 divided by positive 3 would give me that x is negative 1. My next step then is going to be kind of in reverse. To find the value of y, substitute the value we just found for x. So we just found an x. We're going to substitute that in, and we're going to go back to equation 1 because that's a simpler equation. So if I go back to number 1, I'm going to say negative my new value of x, negative 1, and I'm going to add y to that. And now I'm going to solve for that y. So negative negative 1 is a positive 1 plus my y equals 1. Get my constant terms together, so we need to combine this one with a negative 1, leaving me with just y. And I did that on the other side. I need to do it on this side. Combine this one with a negative 1. Be careful, they do not cancel out. We made that mistake before. Now I have that my y equals 0. The next step would be check that negative 1, 0, our new coordinate point, is a solution by substituting the negative 1 for x and 0 for y in one of the original equations. Okay, and when I do that, I can still use my my simple equation here and substitute it in, and I can go ahead and I could say is a negative negative 1, which is positive 1, plus 0 equal to 1. Yes, a negative negative 1 is a positive 1. 1 plus 0 is 1. I could also go to the other one because I used the first one. So I could say 2 times negative 1 is negative 2, plus y, which is 0. And so I have negative 2 equals negative 2. It works for both of those. And yes, the solution is negative 1, 0 then. We found the coordinate points that work for both equations. I'm going to go ahead and pause this in case I need to break this up for time's sake. We continue to use substitution as a method. We will go about it slightly different. This time we will actually solve for x. We have our two equations, and we are going to solve for x because in the second equation x does not have a coefficient, so it's easier to solve for it. So the first thing I would do is I will go ahead and I will isolate my x. To do that, I need to add 4y to both sides. I'm going to try to sneak it in here real quick. So adding the 4y and adding 4y, if we can read that. And that is where we get to the solution of x is going to equal 4y minus 1. Okay, that was our solution here. On the left side, we were left with our x. On the right side, we were left with, we now have 4y that we added, and we still had our negative 1. Okay, once we get to that, we now have one variable that we can get rid of by using an expression that we just figured out, the equation here, 4y minus 1. So I'm going to go back to equation 1, and I'm going to substitute in my new x. So equation 1, I'm going to go ahead and I'm going to say 2, and I'm going to substitute in my new x. Now the reason we're doing this is then in our equation, we will only have one variable. We'll have some like terms we can combine and solve for that one variable. So 2x is actually going to be 2 times 4y minus 1. We're going to add, and here's our common variable, adding 2y, again going back to this equation here, equals 3. So we went to equation 1, substituted in the value for x. Distributive, we haven't done this for a little bit. 2 times 4y equals 8y. 2 times a negative 1 equals a negative 2. We still have our 2y here, and that is equal to 3. I'm going to take some shortcuts again. You are more than welcome to write them out so you don't feel like you're missing anything. I'm going to combine my like terms, 8y and 2y. Pretty sure you can do that part. That's what you should do. Whoa, and write your y nicer than mine. So we have 10y. I want to get my constant term on the other side of the equal sign, so I need to add 2 to both sides. That will eliminate it on this side, and adding 2 to this other side gives me 3 plus 2, which is 5. Now I need to solve for my single variable, so I want to divide both sides by 10, giving me y is equal to, I can simplify that fraction into y is equal to 1/2. Over here, now we're to our next substitution. Now we have a y value, so we can now substitute y in the equation number 2 to find the value of x. So we do not have a value yet for x. Looking at equation 2, I'm going to leave x like that, minus 4. And this time I can go ahead and actually add a value into that. And we still have that from equation 2. That is going to equal a negative 1. We have x minus, like terms, 4 times 1/2 gives me 2. kind of ugly too, but we'll follow along. We have my narration here. Add 2 to both sides. Didn't take a shortcut this time, probably should have. Then I need to do my big equal sign. X this time equals -1 combined with a +2. So I am going to have a +1. We have our value for X. We have a value for Y. Okay, there I put it on another page for us. And now we need to check to see if we substitute 1 and 1 for X and 1/2 for Y into each of the original equations, and they make true statements, we have a linear system. So looking at the first one, 2 times our X plus 2 times our Y should equal 3. Is that a true statement? 2 plus 2.5. Does that equal 3? So we have, I'm sorry, so I said 2 and 1/2. I meant to say 2 times 1/2. So we have 2 plus 2 times 1/2. We'll go ahead and reduce that. 2 goes into 2 once. 2 goes into 2 once. So we end up just with 1. 2 plus 1, I'm pretty sure, is 3. That is a true statement. Let's go to the other equation and substitute in. My X is 1. I'm going to say -4 times my Y is 1/2. And that equals a -1. If this is a true statement, then we have a linear system. 1 minus half of 4 is 2. Or again, if I was multiplying it, 2 goes into 2 once. 2 goes into 4 twice. And is 1 minus 2 equal to -1? It is. So the solution, writing it as coordinate points, would be my X is 1, my Y is 1/2. Those are my coordinate points. Again, we can go ahead and look at that on a graph. I've gone and I've taken the equations, put them into slope-intercept form. All the steps there for you. I color-coded it so you can see that this is graphed on the red line. This is the graph shown by a blue line. They have an intersecting point right here. That intersecting point is over 1, up 1/2, and that was our solution. Right here it is in the busy graph on the last page. I had that our solution should be the point X is 1, Y is 1/2. Again, I'm going to pause in case I have to do this in parts.